All right, welcome back to the stream where we build a game from scratch using Love2d and Lua. We're building a top-down adventure game called Tashio Tempo. Now, yesterday we were working on our collision detection for our overworld map objects. So, we've got collision detection for this tree here, and it's just pure AABB collision tree. So, if you look, see how this triggers a collision even though our nose isn't technically actually colliding with it? That's because our AABB collision doesn't have any shrinkage. It's just pure if those boxes are touching. So, and the fact that our Tashio Tempo isn't a rectangular character, he's not a perfect rectangle, so we're actually detecting a collision when we probably shouldn't be. So let's work on that shrinkage here, and then hopefully it'll be more close to what we want, and then we'll be able to actually limit his movement. And you know what I want to do? Okay. So let's get going here. Now we do have, oops, I just chatted an E there. We do have our leader M working as long as Windows Terminal doesn't go back. Let's go check out, I think is it in our player class? We're looking for the collision detection for our player, and it looks like it's this entity collides with the target. So one way that they do this in... Hey Holden, how you doing, bud? Should look at the camera.
How's it going, Holden?
That's the Holden cam right there. There are some shortcuts we can set on the Stream Deck that we could like punch in, make my camera bigger. So like maybe we'll mess around with that, but who knows? There's a lot of config stuff we can do. Now, one way to do this is not to check whether or not, like we would just give our collision detection a couple pixel worth of buffer. So we wouldn't be seeing if the very left side of us is colliding. We would see if 1 pixel over, 2 pixels over from us is colliding. So I guess what we can do here is go into our constants, and we'll go give us a constant called like collision buffer or something. Collision buffer, I don't know. Let's do 2 pixels. So we'll go, I guess 2 pixels in from every side just gives, you know, a little bit of that buffer here. So what we can do is we would want to check if the right, in the collision detection, this is the right side of us being smaller than the target. Now we have to kind of decide if we want to just check the collision buffer with both entities or just entity that we're running the collision function on. So I think we can do it just on our entity, so just on our self items here, and we can say that if the right side of us minus that collision buffer is smaller than the target X, this is all the not collisions because this function returns the opposite. So then we're going to be seeing if the left side of us is greater than And let me just make sure we're doing a correct addition or subtraction here. The right side of us would need to be bigger than the left side to be a collision. So if we want that buffer, we need to subtract the 2 pixels. Okay. Then if the left side of us is greater than the right side, so we would say left side of us minus 2, minus our collision buffer. Did you crap out there on the slots? Okay, then if the top of us, no, the bottom of us is smaller than the top of the target. Now we want to see if not the bottom of us, but the bottom of us plus 2. I can't tell if this is right. We want to determine what isn't a collision in this function, so we're saying the bottom of us would be smaller than the target's top. But we need I think we need to add our collision buffer here. And then the top of us would be greater than the bottom of there, but it'd be the top of us minus the collision buffer. Maybe. We'll see. So now that we've got that, we've got a little bit of shrinkage on our collisions. Now, let's see. See, look, we did it the wrong way. Because this shouldn't detect a collision. That's way far. And then same with here. So I think we need to do the opposite of what we just did. Let's try that. Now, okay, see, this is wrong. We should have two pluses and 2 minuses, I believe. So we're checking if the right side of us is smaller than the left side. You know, I think that minus is right there. And then the left side of us plus our buffer is greater than the right side of the target, the left side of us minus our buffer, and then the top of us minus our buffer is smaller than the top. That sounds right. And then the top of us plus our buffer is greater than the bottom. I think this is a minus as well. Well, let's see. That's all minuses. That still looks way off. Oh, see, like that looks good. That looks good. It looks right on the Y. It's just that on the X, it's jacked. Okay, that's looking a lot cleaner. I was literally just guessing. I just replaced some pluses and minuses until it worked. Okay, so yeah, see this? Like, this technically shouldn't be a collision, right? I mean, it could be. It's just very close. We're not literally colliding, but I think this is okay. And you know what? I do want to give us the ability to walk a little further down than we currently are. Because we trigger a down. Hey, nice catch. We trigger a down transition, I think, a little too soon. And then yesterday, we also found a little bug where we were stuck in our walking animation after the end of a transition, and I'm not sure why. I haven't been able to recreate it. I'm going to go ahead and remove our collidable debugging here. And then we're going to go, I think it's in our scene for our event dispatch. Yeah. Where do we event dispatch? It looks like it's in our player class. Okay. So I think for our down transition, we don't want it equal to or greater than the screen height limit. We want an extra pixel or two there. Dude, you got 125 gold. Dude, I think you can almost get a legendary Pokemon. I think I made him like 125 or 150. So you could get like Lugia or Ho-Oh or something. They're pretty big, which is why I made them so much gold, because I didn't want like someone spending 10 bucks and getting a Lugia and him taking up so much space. Okay, let's see if we can walk down a little further before we transition. We should be able to kind of walk on top of the bar just a little bit, like the Manus bar here. Huh. Okay, I see what's happening and I know why it's happening. Okay, so this makes sense. So like yeah. Yeah, you definitely could. You've almost got enough money to hawk a big Lugia. Okay, so I think in our player class, when we're limiting we should be limiting our downwards movement, and we can add better comments. We need to start commenting better. I think it's in a player walk state, maybe. Yeah. Okay. So this is us moving down, and this is the line where we limit our Y to be equal to the screen height limit minus the player height. So that's why we lock it at the very bottom there, and that's why we can't trigger a collision or a down transition when it's there. So if we do a -2 here, and I don't like putting in a magic number like that. I don't like doing that, but if this fixes it, we'll go and add a constant. So we should be able to walk just on top of the bar there. Okay, it's a +2, it's a +2. Another thing that irks me about Windows is like in Tmux, we lose the ability to have a blinking cursor in Tmux. Okay, well, it looks like, see, look, this is like flush on the bottom. Okay, and then this is like 1 pixel below, but in Link's Awakening, they render the player. See, I shouldn't be a. We should render our player after our HUD, so it goes on top just ever so slightly. But that does. Oh, see, look, this is the bug. We're stuck. We're stuck in a walking animation. I don't know how we did that. But if we go to another page, it looks like it does fix it. And then we saw some weird collision stuff there when we switched transitions. Oh, yeah. We want to clear our collidable map objects table during a transition so we don't get a weird flash like that. So we would want to do that. And then we need to render our player on top of our HUD, just in terms of render order layer. And we need to give ourselves a, I'll just call it bottom buffer. I don't like, I mean, it's better than a magic number, but I don't like that I call everything just buffers here. So we'll say our bottom buffer here. Oh, and you know what? Well, yeah, we want to keep them decoupled just in case we switch the collision buffer. But in our scene, I think we've got... No, I think it's in our player class, in our event dispatch, we have this +2, which is a magic number that we need to switch to be our bottom buffer. Okay, so now it should be the same, but we should hopefully not be... Okay, yeah. So let's just work on getting us on top of the HUD there. And that's merely just a nostalgic thing because Link's Awakening does it like that, and I just really like that game, so what we're kind of basing off a lot of this stuff. Now we render our HUD where? It might be in our play state. Yeah. So we render our HUD after our scene. Oy, okay. Yeah. Since our player's part of our scene, we can't really do this. What we could do... See, and we need our HUD outside of this push and pop because that's how we're translating the graphics off screen during a scene transition. So I don't know if there's a way we can do this. Okay, so yeah, I don't know if we just give up on this idea. It looks like we moved too far up there. Yeah, see, we shouldn't end up like 2 pixels above. Yeah, we shouldn't end up there. So we need to change our tween value. See, look in here too. Our tween value should square us out at like the very right side. Okay. Yep. Okay, so that's good. Like, I like that our nose can kind of peek off here before we initiate the transition, but we should end up kind of flush with the left side instead of having a gap there. So let's get that fixed. Now, yeah, we can't have our HUD in the scene because the scene is literally being translated during the transitions, so we can't really do that. That's okay. But let's go to, where would it be? Player walk state. And it would be, we're looking for the tween values. It's in our scene. Okay. Okay, so when we initiate a transition, we tween our player's X. Oh God, okay. See, look, I've got this where player ends up on the screen. Now, if it is if a shift X is negative, then RX is going to become the right side of the screen. Now, see, so this is why this edge buffer player is the reason why we're getting a space that is different. I think we ended up doing this so we don't accidentally trigger another scene transition by the time we're done. But let me just see if we take out, and this in this case would be 0. Then we would take out this edge buffer, and then this would be a 0. Yeah. Let's see if that ends us up at the right location. So look, I'll peek out. We're going to do a right transition, and then we end up flush against the left side like that. Okay, that's good. That's what we want. We do need to flush. See how these red squares are just rendering like that? That tells us we need to flush our collidable objects for our current map. Okay, that looks right. That looks right. Now we're transitioning better. I'm curious about the walk bug that we've had. We recreated it once, but I don't know if I could do it again. There's a Stream Deck plugin I was trying to get to work, which would show our upload bitrate to Twitch. It's not working though, and I can't test it unless I'm streaming, so I might just have OBS open all the time like that, so I can keep an eye on that. It would be nice if we had that plugin though that was working. Yeah, I like it. Like, I've got the amount of viewers up here on the Stream Deck, which is cool, but I can't get the bit rate to work. And what sucks is, like, I had to download this other bot app, give it all my stuff. Like, I didn't log in, but I had to kind of configure it with the Stream Deck. But it just isn't working. Oh, and you know what? I do want to test. I want to see what our RAM usage is when we're running our game and streaming and recording. I guess it would just be in Task Manager, right? Okay, well, actually, we're only at 20%, 28% memory, so that's not bad at all, actually. I was thinking we needed to update our RAM, but we're looking fine. I think just the longer Windows is turned on, the more bloat kind of just sits in the background, because this is a lower RAM than it was before we started the stream. Okay. Okay, so I think we also want to clear, once we begin shifting, I think we want to clear. Hey, Flan Must Die, welcome back. Good to see you again. We are working on, right now, we have collision detection for this tree here, but if we walk off screen, we get those red squares, which we're trying to fix. And then, yeah, so Flan, you know what? If you know the Pokemon Gen 1 or 2 name, the correct name and spelling of that Pokemon, you can buy it in the store and switch your avatar. So what I can do is say, I can just give you 30 gold here. So I can say, Flan Must Die, give you 30 gold. And then all you have to do is say avatars. Oh, what is it? I think it's buy. So you say buy avatars, and then you could say something like this. Like you can say buy space avatars and then whatever name of the Pokemon you want, and then you can change your avatar. If you don't want to be Sentret. Maybe Sentret's your favorite Pokemon though, so. So yeah, we're trying to fix that. Those red squares. I keep accidentally chatting E. So our collidable map objects. This is just our tester. Okay, so I guess for now we'll flush our tester object. But ultimately we'll need to go and flush every item in that. Every item in that table. But for now, let's just flush this with an empty table, and it's from our scene. Yeah, almost. You just need the U there. That's close though. Hey, nice. And it should change you automatically. There you go. Hey, look at you. That's awesome. That's awesome. There we go. Did it work? Yeah. Hey, look at us. Look at us, kids. So our collidable object is in our scene. So we need to flush this upon a scene transition so we don't get that bug. So what we could do is put it upon our begin shifting. We would say our self.object gets an empty table. Oh, that's sweet. Self.object gets an empty table. Okay, so I'm thinking that this will fix the bug because anytime we begin shifting, we're wiping that object of our collidable map object. So we shouldn't have anything to render red by the time we walk over here. And let's see. Okay, we crashed. Attempt to compare a number with nil. Why? Is that really what crashed us? Is our... Okay, that's really weird. What? We're not comparing a number, we're just flushing an object. Okay, maybe we can remove the only object that's in that table. So instead of saying it gets an empty table, maybe we say table.remove, and the table we want to remove from is our self.object, and the index is 1. Maybe that'll do it. So we've got collision there, and then if we go off here, we're still getting those red squares. So what could be happening there? Now I believe we're... Oh, you know what? I think we are actually doing more than just the tester object. Yeah, we do need to flush all of our collidable map objects. That's what's happening. So we do need to flush those. We do need to just delete them upon a transition because we need to get the new collidable map objects for whatever new map is going to be on screen. So I guess I want to see where so yeah, Flan, the I believe it is 10 gold for the first gen Pokemon, and then or like the first evolution, and then 20 for the second, and then 30 for the third evolution. So I gave you enough gold to just buy a Magnemite, which, or I guess Magnemite would have only been 10 or 20 gold. So you might have some gold left over. So yeah, we do need to flush these collidable map objects. Now, where do we populate these collidable map objects? We don't want, I believe we don't want our self.object anymore. We don't need it anymore because we're actually doing... Yeah. I believe we can just get rid of all this and still work. Yeah. Okay. So I want to see where we assign our current map collidable map objects. I think it's in our map instantiation. So if we go to our map init, we can see that our... See, I was thinking it was... Oh, yeah, it is right here. So collidable map objects here. And then we go through and we assign a collidable map object instantiation inside this table as long as our tile ID is within those designated ranges. Okay. So I guess what we need to do is wipe our current map's collidable map objects table upon a scene transition. So if we go here in our scene, we have access to our current map. So we would need to go access that current map during a transition and then go flush its collidable map objects table. So upon a begin shifting, we can go and say that our self.currentMap dot hey, nice catch, Flan. That's good. Current map dot collidable. I already forgot the name of it. It's in our map class. It's called collidable map objects. So collidable map objects is gonna get flushed to an empty table once we're shifting. And then we'll see if that fixes our little bug here. So we've got our collision detection working, and then when we shift off screen, hopefully no red anymore. Cool. Okay, so that makes good sense. And then what we actually do is we set, I believe we set our next map upon finishing shifting. Okay. So yeah, we can't collide with anything upon a begin transition, and that's okay because we don't even update our X or Y position at that point. Okay, cool. So we've got that. Let's test a little more collision detection. And you know what? We might want to move our tree to be over to the center so that we can check all aspects of our collision detection. So let's go ahead and move our tree. So how we would do that is go into our map declarations. And for our 1-1 scene, we've got, instead of the tree being down here, we want the tree to be over, I guess, where the flower is. Top left should be where the flower is. Yeah. So where the flower currently is, we'll put our tree top left. Then we would need to put our tree top right. And then the others, bottom left, bottom right. And then we can take out these and just put, we could put a grass left edge and then a grass bottom right. Bottom left, actually. Do we not have a bottom left grass? Left edge. I think we should have a BL grass. Maybe not. Okay, grass here, and then a grass bottom edge here. Grass bottom edge. And then we'll see if we've got a grass bottom left. We should. We don't. Okay, so what are we doing for... If we go into our constants, we can go see our grass declarations. So we have a top left, a top edge, a top right, a left edge, then a grass. Oh, we do have a grass bottom left. Okay. We do. It should work. So if we go run our game now, we've got, okay, we're rendering the flower over the tree, and that's because we actually insert it because it's an animation. And I think we do that. This is one thing I do want to change, because I would like to insert the animations based on the tile numbers as well. So like maybe we have, just like how our collidable map objects are in a certain range on our quads for our master tile sheet, I think we want to do something similar for our animations. But right now, where are we inserting? We're inserting our animations here. I think we're hard coding in a flower insertion, but I'm not seeing where we do that. Yeah, I'm not seeing where we're doing this at the moment. Now it should be a flower animation, so maybe we can just search for flower and see. Nope. Well, we know that our animation class is called insert animations, so we can just see where we insert animations and see where we put. Really doing it only there? For our map init, we go insert animation. Okay, this is jacked. We don't want to. We insert an animation object. So maybe our insert animation class is where we're hard coding in the flower. So we'll go try to find that. Insert animation here. Yeah, see how yeah, we need to change this, because this doesn't need to be. Are you talking about the live action Mario Bros, aka Bob? So we give the 2 quads of the flower, we give it a duration, and then this is jacked up. We don't want to do this. This took us like 2 episodes to figure out, but this isn't the way to do it. Now we don't want to insert our flowers. Yeah, you know, I like that movie. I'm not gonna sit here and say it's good, but I like that movie. I think I heard that they're making a new animated Mario Bros. Coming out in a couple years. Okay, you know what? Instead of changing this, we'll keep this, but when we go and insert the animation, I think we want to say, not what we wanted. We want insert animation. Yeah, I think we just want to not do this. And we won't have an animation for our other flower. Oh god, map 39. So we'll take this out. Because that's what's hard about the animation, is that if we want the flower I'm standing on right now, if we want that to update, we have to update the quad, you know, over time. And in order to do that, we need a reference to like where the X and Y is over time. And then there's also, you know, a potential of 100 different scenes in our game right now. So we needed a way to kind of find and keep track of those things. So it's messy the way we have it. We're gonna redo that. But let's check our collision detection. See, look, this is jacked. Our right collision detection shouldn't be right there. But what is cool is we're not detecting collision over here, because the game knows that these tile IDs aren't a collidable map object value. So it knows it doesn't need to check collision for those things. We're only checking collision for a collidable map object's amount of things, and that gets populated upon a map init, which only happens once at the end of a scene transition or at the start of the game here when we init our map for the first time. So it looks like our right detection or us coming in from the left works. Us coming in from the top looks pretty good. Us coming in from the bottom needs to be shifted a bit because look, this shouldn't be a collision right here. So it looks like us coming from the bottom is jacked and us coming from the right is jacked. So let's see if we can fix that. Now, I believe that this is in our entity class. Yes. Okay, so if we want us coming in from the bottom, that should be the top of us. So just our Y. So maybe this is a plus instead of a minus. And then us coming in from the right, maybe this is a plus instead of a minus as well. Let's see if that's looking a little better. Nope. Oh, it looks better. It looks better for the bottom one. Like, that's looking good. So everything but... Oh, gosh. Well, now that's jacked. Yeah. We're close, but we screwed up our left collision. Actually, that's okay. We screwed up our bottom collision. Now. Okay, and you know what? The way we wrote this is just really confusing. We're asking, like, what isn't a collision, and then returning the opposite value of that. Okay, this is looking pretty good. See, like, do we want to allow them to kind of walk like that much over it? That's part of our collision buffer that we'd have to decide, and it's like a 1 pixel sort of deal. I think it's actually 2 pixels, but see, like there, we detect it. Actually, this is looking pretty good. Well, except right there. Yeah, this. Yeah, okay, so just the right side of us is messed up. So when we're checking the right side of us, it should be this one, and maybe this is a minus the collision buffer. And let's see. Okay. See, like, should that be a collision? If it is a collision, the only thing that's going to happen is it's going to move our X and Y so that we're no longer colliding. So I think it's okay if this turns out to be a collision. I think we have to decide how we want to move our character. So there's 2 ways I see about going about this. And we could do... we could add that we check what type of collision this thing is. Like, oh, this is a left collision because it's colliding with the left side of us. This is a bottom collision because it's colliding with the bottom of us. And then if we are top colliding, we're going to move our Y down so that we're no longer top colliding. Because as far as the game's concerned, if we end up, like, let's say, you know, over 60 frames a second, if we end up here on an update, on a delta time, where would it move us? Would it move us up so that we're not bottom colliding, or would it move us right so that we're not left colliding? Because right now, we only have AABB collision, so it's just gonna be, it just knows, hey, we're colliding, but it doesn't know how to respond to it. It doesn't know which direction to move us. So I don't exactly know what we should do. I kind of think we need to break up our AABB collision into separate sides. But then the issue with that is we have to kind of choose what priority the collision gets, like in the sense of if we have a left and a top collision detection, does the top collision go all the way through all the pixels on the top? And that means that left collision can't be detected on that very top of the pixel. Or we negate a little square here. Like maybe I can draw this better, but I kind of feel like if we imagine let's pull up a sprite and I'll show you. So our tile is 16 by 16. Now imagine this is our character for our collision detection, and we want the collision detection here to be, let's say 2 pixels tall or something. So like this would be a top collision, and this would be a bottom collision. So if instead of this whole square doing collision detection, and we would know, hey, that's a collision, we would be able to say, hey, this is a top collision because it's AABB within this box. Now, the reason I say we give it a little space here is that once we add our other side collisions, if we need, and this is, we're only doing it based on a rectangle. So the question is, these rectangles overlap somehow. So like, if we leave a little bit of a gap here, then we could do something like this. Because if we expand this out, then we can't detect a top collision on the top left or top right corners. So that's why I'm thinking to leave a little gap. Like maybe we do something like this. So like this, we would be like, we won't be able to detect a pixel perfect AABB collision, but the sprites aren't going to line up like that. So I think that's okay. I think we just want to do something like this, which gives us, if we're colliding only on the top pixel here, it would trigger, okay, that's a top only collision. But it's a little more jacked up than that, because we want to shrink our collision boxes so that we don't collide right away, because the square collision just comes on too early. So right there, see where we're kind of walking over the tree, but we don't want a perfect collision because our sprites aren't all the way out to the edge. They're not perfect 16 by 16. So I guess, we just have to decide how we want to do this. So I kind of feel like we don't want them to overlap. I feel like we don't want them to overlap, because we don't want any order of operation business going on to determine what collision it was. Yeah, I think we want something like this, because we need a little bit of buffer. And we might need this, because we need the buffer, or we need I think we need this, which is just 2 pixels on either side. So if we change our AABB collision to be 4 functions instead of 1, and we would just, because we have to do a different thing based on different collisions, because as far as the game's concerned, like if we land here in a delta time, we need to know whether to move us to the left or move us down. And that depends on what type of collision it was. So if we end up here, you know, this we would negate that little window here, so it would probably trigger a right collision in that case. But if we're more down, like something like that, then it would trigger a top collision, which would just scoot us down. So I think this is what we'd want to do. But it does mean we'd have to split our AABB collision into 4 different collision boxes, but that's okay. So it would be cool if we could write these functions to render the hitbox that it is detecting over our player, over our entity. So maybe we'll do that, and then we can test and make sure it's working like we wanted to. And then the last step will be to actually modify our Y position and X position. So I think we're gonna go with this, which is a 2 pixel buffer on either side for our AABB collision. And then there might be certain other instances that we want to do true AABB collision. That was close, Flan, that was close. I think there is an instance where we might want to do true AABB collision, but we can get there once we have a case for that. So for now, let's just work on these. It wouldn't be the collides, it would be a top collides or left collides. Hey, nice catch. Here, I'll give you guys another one. Yeah, so we want other functions here. So we want a entity left collides with the target. And then we want, we want left, right, oops, top and down. That's too many. So we want okay, here we go. Alrighty then. Let's do this. Right. Then up and down. It would be, I think it would be a top or bottom, actually. Makes more sense. Top or bottom. Okay, so let's see. Let's take the top first, right? So we would want to do where we return the value if, and up here we do it, we return not. So we ask an or, if this is happening or this is happening, and then we say or this is happening or this is happening. So if any of those things are happening, then it is not a collision. So let's do something similar, because we want to do, like, we know it's not a collision if our X, so yeah, we need to shift. Okay, yeah, I might need a pencil and paper to write this down. No, there shouldn't be. Hey, good catch. Yeah, it is not entity. It should be entity. Good catch there. Yeah, definitely. I have a hard time typing entity. I don't know why. Okay. So if we go about our top collision function here, now we're seeing if the top and okay, so we're running this function on an entity. So our self is the entity. So our self is the player. So in that diagram I just drew, that would be references to ourself. So we need to check the X and Y position against ourself there for the target. So we would know that, see, and we would want our self.width, X plus width would be the very right side, but we want to modify it by that collision buffer. So we would subtract this collision buffer to give us that little window. But we would want to make sure that this is smaller than the target X. And then the other side of that is the left side of us. So it would be plus our collision buffer here would have to be greater than the target X. And then here's where it's different than the true AABB collision, because we would say target width, and then we need to also ask or, and we would say it's not that we're checking the top of us, it would be, or the bottom of us rather, we would be checking the bottom of our collision buffer, which is 2 pixels, I believe. So the top of us plus our buffer, we're trying to see if that value is smaller than the target Y, because we're trying to ensure not a collision so that we can return the opposite. And then we would say that the top of us, and actually it would be the top of us, this is the bottom of our buffer. We would say that the bottom of our buffer would have to be greater than the target Y. Okay, let me think. I think we want to do this the top. So like this condition here after the or is seeing if the bottom of our, not this, A sprite. We're seeing if this line here is actually smaller than the top of our target. So no. That's here. Smaller than the top of it, or we're seeing if the top of us, okay, so yeah, this one would be if we're seeing the top of us would be greater than the target Y plus the target height. I think. So let's see if we can, it's almost like what we can do is we'd want to render our little entity here with a top collision box if we're top colliding. So let's just try to get that top collision box rendering first, and we'll say that we want a rectangle here, and we give it a fill type. We give it an X and a Y, which would be our player's X plus our 2 pixel offset. We could do collision buffer, but I guess for now we'll just put our X would be that, our Y would still be our Y, and then our width would be 16, so a tile size minus 4 for the 2 pixel buffer on each side, and then it is a 2 pixels high. So let's see if that renders a little, yeah, so it renders a little top collision box there on top of our heads and all our entities' heads. But what we'd want to do is set our graphics color to red for the collision detection. And then we only want to render this if we are actually colliding with, and then we've got to actually, Yeah, let me just see. We should have little top collision boxes on our heads, but we want to only render them if we're colliding with one of these things. So right now, where we're doing the collision printing, well, it's actually, our collision printing is based on our collides function. So if we go search for our collides, we need to do this, but in our entity class. And we would switch it up so that we're not, we need to check if we're colliding. We're trying to check if our self, not our self.player, we're trying to see if our self collides with a collidable map object, but our entity doesn't have access to this current map collidable object. So we might need to do this outside. We would want to do this outside. Okay. So I think what we want to do is where we're currently doing this, we would say instead of rendering that thing, we want to render our box to our self.player's head. Self.player.y. Let's see if we get it there still. And it doesn't give it for the geckos, which is good, but we want to do it only if our top collides function is returning true, because we want to check and make sure that our collisions are working as expected. So what we want to do is we wouldn't do this. We would only do this if, and we would have to cycle through all of the collidable objects we have in our map. So we would say current map, collidable map objects, do, and we would check if our player, and we don't want to check our collides, we want to check our top collides. And the entity that or actually the target parameter that we're checking is going to be a self.currentMap collidable map objects at the index of I. So for the tree being on screen, there will be 4 collidable map objects, each with an X, Y, width, and a height. And we're going to be checking our player to collide with any of those, or to top collide with any of those objects. And if we do collide with it, we're just going to go ahead, if we do top collide with it, we're going to go ahead and render that top collide square. So now we shouldn't see it here because that's not a top collision, but right there it is a top collision, and our little red square is proving it. So that's looking right for our top collision, actually. Okay, so now that's left to do, we want to get our right and left collision, because look at right here, we trigger a top collision, which is true, because our top little window there is actually colliding with a target. But we would want this to default to a right collision, and we wouldn't be able to get this far into an object because it's a collidable map object. We shouldn't be able to get inside of it. We would detect whatever collisions detected first. That determines the position that we move our body to prevent that collision from happening. So as long as we get our other functions here, we should be able to test. Let's go into our entity. Now we've got our top collision. That's looking right. So let's do our bottom collision. So we're going to return the opposite of an impossibility of a bottom collision. So we're going to be checking the... it's hard to think about this because it's like we're trying to... The return not here is because we're asking whether or not a collision is impossible. So like we're checking what couldn't be a collision, and then we're returning the opposite. It's a little weird, but I think it's almost necessary because we can't guarantee. Well, no, we could swap it around so that it's returning true upon a collision, but all these ors would have to be ands, so we'd have to check inclusively. If all these things are happening, then that has to be a collision. But this is how we're doing it. So we're going to be checking the right side of us, but we want to offset by our collision buffer, our 2-pixel collision buffer, and we're seeing if the right side of us is smaller than the target X, or if the left side of us plus our collision buffer is greater than the target X plus the target width. And then we say or, and we do, this is where it's going to be different than our top collides, and we're going to say if the top of us, and the top of us is actually, the top of our bounding box for our collision detection is actually going to be a self.y plus a self.height minus a collision buffer. That'll be the top of our box. We're trying to see if the top of our box is smaller than the top of the target, because that would mean an impossible collision, or the I think this is actually. Hey, thanks for the follow, Nervaska. I appreciate it. Yeah, we're trying to get to 40, so thank you. You are almost tipping us over the edge here. Here, I'll give you some money if you want to buy avatar. You can buy a Pokemon to become. I'll put Nervaska. I like that name. And I'll give you 30 gold here. Maybe it doesn't work. Maybe I spelled that wrong. I'll try to figure it out. If you want an avatar, let me know. I'll give you some money to buy a Pokemon. And we'll try to, let's see. So we're checking the top side of our collision box for our bottom detection, which would be, the top side would be the bottom of us minus the collision buffer, and we're seeing if that is actually, the top side would have to be smaller than, actually it would have to be greater than the target's y plus height. And maybe we should do this similar with here. So on our top collide, we're checking if the top of our box, this is actually the bottom of our box. So yeah, let's do the bottom of our box. So it would be a self.y plus self.height would be smaller than the top of the target. Or, and this is where we'll do the bottom of our box, which will be a self.y plus a self.height minus our collision buffer. And we're seeing if that is greater than the bottom. So yeah, the bottom, or the top of us is greater than the bottom of the target, and that would be an impossible collision. So target y plus our target height. Okay, so that should be our bottom collides function. So let's go back to our map here, and we're gonna do something very similar, but we're gonna be checking for a bottom collision. And if we bottom collide, we want to render a bottom collision box, which would be an X position of the same, a Y position of the, it would be the Y plus the player height minus our collision buffer, that would be the Y, and then it should be the same width and height. So now let's see if we've got bottom collision where we spelled width wrong. So we spelled width wrong in our thing here. Width should be right there. Okay, let's try that. Nice, look at that bottom collision. So look, if we in here, it detects a bottom and top collision, but we would want to prioritize the right or left. So we're getting very close here. That's interesting. You didn't, like, you just didn't realize it was glow in the dark until today? Like it was one of those secret shirts, I guess. Okay. So here, we're going to be doing our left collide function. So we're going to be checking the left side of our collision box, which would be, and actually we're going to do this. Yeah, let's do this. We want to see if the left side of our box, which should be our self.x, we're seeing if our left side of our box is greater than a target.x plus target.width, or when this is going to be the right side of our box, which is going to be, since it's on the left side, it'll be a self.x plus our collision buffer, and we're seeing if the right side of that box is smaller than the target x. Is that right? We're seeing if the left side of us is greater or the right side of us is smaller. Yeah, that's right. And then we say or, and then we can say the top of our box, which is going to be our y plus our collision buffer. That's that 2 pixel buffer on the top there. We're seeing if the top of that is greater than the target y plus the target height. Or we're going to check the bottom of our collision box, which would be a self.y plus a self.height minus a collision buffer. So the bottom of us, but 2 pixels up, and we're seeing if the bottom of us is smaller than the target y. I believe that should be it. So now we can go back here and we add in our left collide, and we can say, hey, if the player left collides, we're going to render it at a player x and a player y of a plus collision buffer, because this will be the top of that square. So the top of us plus 2, and then it is actually, we need to swap these, a width of 2 and a height of tile size -4. Oh, hey, thanks for the raid. Hey, Very Real Dev, I have not heard of you, but I really appreciate the raid. That's awesome. So we're building a top-down adventure game like Link's Awakening, but we're a spellcaster, and we're working on collision detection right now. So we've got, see how we've got a collision detection with the tree here? So like we're rendering a little red rectangle if we're colliding. So what's next is once we get our right collision, we will be able to determine what to do with our player upon a collision, which would stop us from colliding, hopefully move us. So we've got our top collision working, we've got our left collision working, and we've got our bottom collision working. Hey, thanks for the follow. I really appreciate that. Are you a lurker on this channel, or did you just find me somehow to raid me? I appreciate you. So yeah, we're almost on our right collision. So let's get our right collision done here, because we're so close. So we'll say, now we need to check for our right collision. So we're going to be checking if the left side of our box, which is going to be a self.x plus a self.width minus a collision buffer, that's the left side of our box, would need to be greater than the right side of our target. So we're seeing our target dot x plus width. Hey, nice. Well, dude, yeah, I really appreciate it. You're very welcome here. I think you got a Pokemon on screen. If you want, since you rated me, I can give, I actually want to give everyone on stream here some money if they want. We can say currency, is it add? Oh gosh, I forgot it. What is it? There we go. Everyone gets 30 gold, so that should get you a level, a third evolution Pokemon if you want. You would just have to buy it with stream avatars. It's buy space avatars and then whatever Pokemon Gen 1 or Gen 2 you want, and you can change it there. But I appreciate the raid, man. I really do appreciate it. I'll check out your page when I'm done here, and I'll see what you're up to. What programming language you use and what game engine you use. Okay, so we're seeing if the left side of our right collision box is greater than the right side of our target, or the right side of our collision box, which would be a self.x plus our self.width. The right side of our box would be smaller than the left side of the target, or the top of us, which would be a self.y plus our collision buffer for our right collides function. Yeah, the right side of us, so the top of this box would have to be greater than the target.y plus its height, or the bottom of our box, which would be a self.y plus a self.height. Using C# on Unity, been experimenting with Unreal and a little bit of Python too. Hey, that's great, dude. Yeah, I have not dove into Unity, mostly because at least recently, the thing where they wanted to charge everybody per download, I didn't like, but I took the Harvard CS50 game dev class, and they do Love2d and Lua stuff, so that's kind of what I've been on. And it's cool because I like the low levelness of it. Like it's all through code. There's no like interface, so it's kind of forcing me to teach myself how to like organize all the data for my games. So I appreciate that about it. So yeah, we want to see, this would be the bottom of us. So y plus height minus our collision buffer would have to be smaller than the very top of our target. So if we did this right, we did that right and no errors, then we can go in here and we can render our right collides box. Always nice to meet a fellow game dev on stream here. I like that. I mean, I figure a lot of people watching on the channel here are at least interested in programming. I don't think you can kind of sit through this without being somewhat interested. Okay, so the X for our box here would be a player X. Let's see, this is the right side, so it would be a player X plus a player width. Who just farted? Who just... Okay, yeah, this would be a minus collision buffer. So we want the X of the right side of us to be X plus our width, so the right side of our character minus collision buffer, and then the top of us would be a player Y plus the collision buffer, that's right, and then it would be a width of 2 and a height of tile size minus 4. That should be right. Let's see if we've got our right collision working here. Yes, yes, yes. This is great. So yeah, we've got all the sides. So now the question is, it's like once we detect a collision, we want to see like this, instead of our old way, which is just, hey, we know we're colliding. Now we can say, hey, this is a left collision, so let's move us to the right so we're no longer colliding. So that'll give us just the ability to do better, more accurate player replacement once we do it. Yeah, well, I mean, yeah, I'm interested in Unity, but I like the open sourceness of Lua and Love2d, Love2d. So I'm gonna be sticking here for a while, and I think a lot of these skills kind of translate to other gaming engines because you kind of have to manually do a lot on here on Lua or on Love. But let's see if we can now use this function to limit our X and Y so that we can't walk through a tree finally. And what's cool is no matter where we put this tree on our map, it'll only detect collision for the sprites, for the locations that the tree is currently in, because it detects collision based on the collidable map objects. And those collidable map objects are populated on a per map basis. And that is generated based on the map declarations for the tile IDs. So since the map knows that this is a tile ID of a collidable object, it'll only check collision on those objects. So since there's only 4 tiles in there, we're only cycling through a total of 4 tiles every frame to check those collisions. That's how it's currently set up at least. But let's go ahead and see if we can't limit our movement now that we've got that. Now, I missed what Pokemon you guys were. I wanted to see. Oh, a little Abra. Oh, that's cool. So yeah, very real dev. You should have 30 gold if you want to buy a different Pokemon. I don't know if you're into that, but you've got the option. Okay, so I think in our scene here, we want to check for this collision, right? So like we're gonna be, this is our old collision detection logic, but we want to see if not if a, dang, aka Bob, you're getting a bunch of gold there. So this for loop is going to cycle through all the map objects. Now in scene 1-1 we have 4, and then we're going to check collision. Now instead of just checking our base collision, we want to do something similar, and we don't want to render a rectangle, because like we kind of proved that we're rendering that our collision detection is working, so we don't need to render this anymore. So what we do need to do is check a collision for all this stuff. So we can say top collides. Yeah, understanding how to build the logic without messing it up, and knowledge would translate to any engine. Yeah, exactly. It's just like, you know, data structures, data management, flow state, input handling. Like I'm getting all that stuff here with Love, except, you know, Love is open source and I'll be able to just share my game. And actually I do share my game. It's on my Git. You guys can all download it right now and play it if you want. It's on the Git repo. I'll make a command that'll spit out the Git repo, and the README in the Git repo has a link to how to install it and play Love2d games. So I'll add that for next stream. I'll add a Git command that will show everybody how to install and play the game on their machine if they want. And then that way you have access to the source code too. So if you want to take it, switch it up, make your own game, you totally feel free to do that. Like this is, you know, I borrowed a lot of code from the, at least for the scene transition stuff, from the CS50 Zelda repo. So it's not, you know, it won't hurt my feelings if you take this code and make your own thing with it. If you use it as a starting point or just to mess around with it and learn the language, like that would make me really happy. Okay, so yeah, we need to check all of our collisions. So if we in fact top collide, instead of rendering that rectangle like we're actually going to modify if we top collide, we want to modify our Y position. So we would say that our player.y is going to become equal to and this is where I think this would work. We need to take the current object that this is, and we would say that our y would become this thing's y plus this thing's height. Which looks a little gross. And maybe the move is to save it in a local variable so we can just say y. So let's go ahead and do that. We can say local, we can just call it local object or local, yeah, maybe we just call it local object. And we're gonna assign this map object to be this current object in the loop. So this way, we don't have to say all of this junk. We can just say object.y plus object.height. That's the y position we're trying to modify ourselves to if we top collide. So if we top collide, we're going to shift our y to be the bottom of that object we just collided with, so we're no longer colliding with it. That should work, and then what I want to do is turn off all of this rendering for our collision detection, just because actually, what is happening here? Oh, we'll add a comment here, and we'll comment out where we're rendering that, because we're not trying to see the red squares anymore. We're just trying to move our player if we top collide. So let's see. We should be able to not move through a tree. Look at that. So look, I'm holding up. We're still walking, but we can't move up. So that's good. That's awesome. So if we do the rest of it, see now, look, it triggers a top collision, which is why it's shifting us down. So that's why we need to add the right collision so it knows how to treat us. And then we'll have overworld map collision detection based on tiles, which is really cool. Hey, Prost Cotilo. I appreciate the first time chat, man. Welcome in. We're building a little top-down adventure game. Hey, thanks for the follow. Hey, I really appreciate that. Dude, we're at 39 out of 40. We're so close to our follower goal here. We've been streaming, what, like 5 weeks now? And we're trying to build up a community here. And it's been so awesome on Twitch. Like, we've been growing really, really fast. I've been loving the community, so I appreciate it. How are you doing? Are you a game dev enthusiast or a coder yourself? Okay, cool. We do got that top collision working. Prosto. Okay, I'll go with Prosto, man. I like that. Okay. We just need our other collisions, right? So we've already got a reference to the object that we're colliding with as our .object. We just need to check our other collisions. So we'll go bottom collides. Hey, I appreciate you, Real Dev. Yeah, feel free, man. I appreciate you lurking. We're gonna go right collides. We're gonna go left collides. And we're gonna say, if we bottom collide, we need to reset our Y position to be equal to the Y of the object that we collided with, subtracted by our self.player.height. So it should be the top of our object minus a player height, that's where our new Y position's gonna be. Oh, nice. Whoa. 3D game in 1 dimension. That sounds interesting. Can you post a link to that project here in chat so I can check it out? Okay, a right collide. We are going to be modifying our X position, and our X position is going to be if we right collide, we're going to shift us to the left. So we're going to take our object's X and shift it by our player's width. So we're going to be subtracted by our self.player.width. I always misspell width like that. I didn't know you could do 3D games in Love2d. I mean, like, I guess it depends on how you're kind of presenting it. If we left collide, we're going to shift our X position. We're going to shift it to become the right side of the object. So the object's X plus the object's width. And there I go again with the width misspelling. Okay, let's see. Look at that. We can't walk through it. That is awesome. It looks like all of our collision detection's working there. Now look at this. We've got... It's like I go 1 pixel into it until I let go, and then it undoes it. Yeah. I don't think I like that. Like, it's still... Hey, that's okay, dude. It's, you know, every game starts out as a mess, you know? It'll get better and keep getting better. Okay. So, it looks like... I don't like how it kind of... Like, if I keep it held like that, his nose is touching the tree, and then I let go, and he scoots back. I kind of want it so that we aren't allowed to go through the tree, or... Yes, I totally agree with you, Stilkin. We can do something like that. Because... You're talking about like the kind of perspective, right? Like, I can't walk to the tree here, but since it's a top-down game, he should be able to walk a little bit closer to the tree. I totally agree. We might do that. Yeah, he's a tree sniffer for sure. So yeah, I guess I'm just not so sure what to do with... We're kind of like touching it. You know, he's a tree sniffer here, and then we let go, and he gets like 1 pixel away. So maybe we just shift our... we don't want to shift our Y position any more than we are, because it's correctly placing us there. And you know what? We're actually going to have a different animation. We're going to have a pushing animation if you try to walk onto a collidable object. So I think we won't actually worry about this, because we'll actually have a different state for our animation, and it'll be like pushing instead of walking. So he'll just be pushing an immovable object in this case. So let's see what it might look like. It's hard to tell if we do... Is that a setup to a joke, aka Bob? I don't... I don't know. Okay. So yeah, we could worry about... We could make our... Like, Stilkin was saying, we could make our top collision a little different to add to the dimension of this game. So like... Right now, our collision detection is part of our entity class. So I guess if we wanted a bunch of different things, like if we wanted, you know, bad guys and bullets to ultimately hit us, do we want that collision to be part of the overall entity class or part of just our map object collidables? I guess it kind of makes sense because because if it's coming at us from the top, it should have a little bit of a buffer built in there. So maybe we do give us that. Now, I guess what that would mean is in our entity class, we would go and check our top collides function, and we don't want to check the let's see. We're seeing if the top of our buffer's smaller than the top of the target, or our top is greater than the top of the target height. So it's a little tricky since we're doing like the opposites here. Like we're trying to determine what's a impossible collision, and we can do. So yeah, this game is it's inspired by Link's Awakening, and we've ignore the geckos there. That's just our entity system testing. But we're a little magic sorcerer, and the idea is thematically it's a lot like Link's Awakening. I don't want to get too much into the story, but right here you see we've got like a red bar called Manus, and that Manus is like our focus, and then the white bar is like the output of our focus. So as we control our focus, it raises our focus indicator, and whenever our focus indicator's in that green spot, it will trigger. That's how we're going to be casting spells in our game. So like you have to use your focus to use your Manus to focus your spell casting, and it kind of like if I just hold it kind of goes up and down at a wild rate, and that kind of resembles like the waverness of your mind, I guess I want to call it. Like just because you're exerting focus doesn't mean you're completely successful in focusing. So that kind of waviness is what makes it adds a difficulty to kind of like get your spell casting consistent, because your mind isn't so focused because and then you can't focus if you have no Manus, so that regenerates. Exactly, like in what is it, Stardew Valley, when you're fishing, trying to balance that. Yeah, I don't know the word for that. Waviness of the mind, whatever that kind of uncertainty of focus is. So once we've got these collision detections set up, then I think we've got our entity system set up, so we'll be able to now make a full spell cast. So like we're going to be giving us, fire entities around us during a successful spell cast. And in order to cast a spell, you need an element. So like you can't just cast magic out of nothing. You need to be holding an item that is going to be the source of your magic. Basically, like I call it the vibrancy of the item, of the element. So like let's say we're holding a torch that's on fire. We can use that torch's vibrancy to cast our magic spell around us, as long as we, use our Manus and then focus our spell casting in that range. So attunement, yeah, I mean, I guess, is that a generic alchemy term or like arcanist term or something? It is inspired by some other fantasy ideas, So like I don't claim to invent this stuff, but yeah, exactly. It's just like a magic term of a sort of you need a source for the magic, and then you're gonna cast it around you, and then over time, the vibrancy of your object will start to become less and less or whatever. So you can't just use fire spells for the whole game if you find one torch, because it's also going to be you have to go explore and find elements to create magic spells with. So it's going to be something like that. But yeah, catalyzer, yeah, catalyst, something like that. Yeah, that's a good term for it. So if we take Stilkin's idea here to change the top collision, and it's not gonna be just with the bottom. I guess it would turn out we want to check if the top of our this is the bottom. This is the bottom of our collision detection for the top. So the bottom of us would have to be smaller than the target's Y. See, I feel like this is wrong. Let's redo this. Top collides. Oh God. Yeah, let's not do that. Let's redo this. I like to build it based off the top first. So the top of our collision box would be our self.x, and we would see if that top, it would be self.y. And if the top of us is smaller than the top of the target. Oh yeah, okay. So we're only doing, yeah, you know what? Let me see what we did have here. Okay, so the bottom of us, oh gosh, okay, I'm getting all turned around here. Okay, top collides. We're checking if the top of our box is smaller than, and we don't need our collision buffer here because the top collides axis box or bounding box rather, is at the very top. So we're seeing if the top of us is smaller than the target Y. This would actually be, okay, I see what we were doing here. Yeah, this is gonna be the bottom of us, yeah. Okay, bottom of us is smaller than that, or the top of us is greater than the height. So what if we say that this is actually, this is our offset for the top collision detection. So let's see if we can scoot a little higher now on the tree. Oh, see? So what's different about this is that we only have, oh, see, yeah, it is different because we're actually still checking for left and right collisions at all times. So if we scoot up closer to the tree, our left and right collision detection is actually triggering here. So that's why we're scooting. We're scooting because we're actually detecting a left and right collision. Now we could change this so that we only check for the collision appropriate to the direction that we're holding. So like we only check for top collisions when we're holding up, and we only check for left when we're holding right, or check for right collisions when we're holding right. That could fix this problem. But I guess it comes down to what we really want to do. If like, does that make it more bug prone than just checking every frame? Because if something gets messed up when we're holding it, we could get stuck inside a thing. So I don't know if I want to do this just yet. Oh. So I think we'll leave it as like kind of true AABB with a little bit of shrinkage for right now. I like your idea, Stilkin, of doing that, and I think we will do that. Just not tonight. We'll add that to our list here. We'll say we'll go to our notes and we'll say that we'll add perspective-based collision detection for map objects. I think that's fair. That's a great idea. I do like that sentiment. So, oh God, I just exited our tmux. That's okay. we'll go ahead and add everything to the staging area with a commit message saying added collision detection, or we'll do it present tense. We'll say collision detection for map objects. That is great. That is a good commit here, and we are missing get push our origin main. Cool. So we've got that. Thanks for watching, everybody. We're gonna be working on that perspective-based collision detection probably tomorrow or the next day or something. But in the meantime, I stream at 7 p.m. Mountain Standard or Mountain Daylight as of today, I guess. But I appreciate everyone watching. I just started a raid to my fellow game dev. Thanks, Stilkin. I appreciate you being here, and good idea. Hope to see you around later if you are into this kind of stuff. I'm here almost every night, so thank you very much, and I'll go raid out here. Peace out.